Hello. So it is a great pleasure to introduce the next speaker, Frank Wuerthwein. Thank you. What the title of my talk is Status of the National Research Platform. And one of the objectives is to talk a little bit about a larger vision that doesn't really have to do with the NRP, but where the NRP is just one element of a much larger vision. And then also make the distinction that there is a prototype NRP funded project funded by the NSF, and then there is the NRP community that I would consider every single one in this room is part of. And when I'm talking, anytime on my slides you see NRP, it's the community. And the few times you see PNRP, it's the project. And so off we go. So I'm trying to talk about the status of the community national research platform. And the way I look at it, in my mind, there's really three challenges that we're trying to address as a community. And or at least there is three paramount challenges that we want to address with a focus. The first one is the gap between those who have and those who can't afford is becoming wider. And we mentioned that a little bit earlier already, and I'll talk more about that in a second. The second one is that the cyber infrastructure needs are growing for education. And that's actually a phenomenon that's fairly recent. And at least on our campus, there's been a phase transition that isn't driven by AI, that was prior there even before AI, and AI is just accelerating it. And that phase transition is that increasingly there are more and more courses we teach on this campus that require computation and data and therefore cyber infrastructure. And 5 years ago, that did not exist. It just didn't exist. And then the last one is a very peculiar technical thing, and that is the end of Moore's Law. And the end of Moore's Law is leading to a proliferation of architectures. And as a domain scientist, it is the last thing I want. It literally scares the hell out of me. And I'll talk about this a little bit and why and how NRP tries to address it. And so let's start with the overall vision for, and I call it the vision of an open infrastructure. And what do I mean by open? An infrastructure that is both horizontally open and vertically open. And I think about this in terms of a stack, right? When you have a software stack, that defines a vertical. There's a bottom of the stack and there's a top of a stack. So you have a direction which is fundamentally vertical. And then you have horizontal means that you grow the total amount of resources available via the platform. And that's the horizontal growth. And fundamentally, what I think we all are trying to accomplish as a long-term vision is to create an open national cyber infrastructure that allows the Federation of CI at all 4,000 accredited degree-granting higher education institutions, non-profit research institutions, and national laboratories. So where does the number 4,000 comes from? 3,900 was written into the Minds We Need. I have not checked this. I just take it at face value from the Minds We Need. And I say there's about 100 national labs and so forth, and you get about 4,000. And that's sort of the scale. And the way that we're thinking about this is that we all know about open science, open data, open source. Those are concepts. They're fuzzy, but at least everybody has a reasonably clear understanding what that is. I think that there is an additional concept required to make this all work. And that additional concept is open infrastructure. Open infrastructure what do I mean by this? It means compute, it means storage, it means data access and therefore content delivery networks. And it means devices, instruments, IoT, edge, whatever you name it. And all of that forms infrastructure. And all of that should be composable in some ways that you can horizontally grow and vertically grow. Vertically build on each other and horizontally scale out that more and more institutions can be participating. Bottom line, being very corny, I'm looking for openness for an open society via a collaboration of all of these concepts above. So why? The why ultimately is democratizing access. The why is that there are 3,900 institutions of higher learning. The US is a very odd place in many, many different ways. One of the odd things about the US is that it has an enormous dynamic range in higher education institutions. It goes all the way from institutions that have 100 students to institutions that have many tens of thousands of students. From institutions that are basically a few buildings to institutions, to campuses that are gigantic with multi-billion-dollar a year research revenues. And being in a position that we can actually serve all of this and serve it in such a way that no matter where the next genius comes from, that genius has access, even when it's not a genius yet, when the genius is still developing. That sort of is the ultimate goal behind being able to integrate all institutions. And of course, this is a rather impossible goal. And so let me talk a little bit about a template of how this could actually work. And the template, the first thing that I acknowledge, there's no way in hell that any federal agency would ever fund something at that scale. I'm just not expecting it. It's not happening. So if it's not, and probably shouldn't happen either, it would be a project way too big. And so what's then the alternative? The alternative is that there is a community with a shared vision, NRP community, actually probably much larger than the NRP community. And the shared vision can be somewhat fuzzy. And then, in addition to that community with a shared vision, we enable PIs all over the country to respond to solicitations that may have nothing to do with that vision. And respond to those solicitations in a way that each project, each proposal to any agency has a scope that is its own, and then has a little bit of an overlap with the vision. And my visual model for this, if I could figure out how to use there we go. My visual model is this daisy, where the center of the daisy is the shared vision, and where each and every project is a petal in that daisy, and petals overlap with the center a little bit. But most of the petal is outside the core vision, because every single project, every single PI wants to have something of their own. They have to have something of their own because they have to respond to a solicitation. If we can establish something like that, then we can all work towards and maybe even accomplish this vision of providing an open type of infrastructure for 4,000 institutions, and while at the same time having the usual way that this is funded via a gazillion projects, all responding to individual solicitations. This is sort of my pitch. And now, how much of this have we accomplished? I'm listing here petals of the flower that is the vision that I described. And I'm probably missing a million of them, or many of them. I've just picked some. There's the Prototype National Research Platform, which is the project that funds the operations of Nautilus, the Kubernetes infrastructure. And it does a whole bunch of other things. It is ultimately a petal here. It has stuff that is outside the shared vision, and it has stuff that is inside the shared vision. Then you have Path. Path runs the Open Science Data Federation on the Open Science Compute Federation. It has an overlap, small overlap with the vision, and a large outside petal. And then you go down National Data Platform that Ilkay was just funded, Pelican that Brian was funded, the Fusion Platform for AI, which is a DOE FES funded project that uses the OSDF and therefore is part of the vision. It overlaps. Then you have R&E platforms for multi-companies. Lots and lots of CC Star awards, in my mind, are petals. Each and every one of them is a petal. They have a 20% overlap with the community, and there is, voila, there is some little piece of it that actually overlaps with the core vision. And that's, in my mind, how we're building a much larger vision, a much larger thing that none of us can afford to build by ourselves. And that's my pitch for all of you guys to think about, and then go and get married with various solicitations, and make sure that your square peg fits into the round hole of the solicitation, and put a little bit of an overlap with the shared vision into your solicitation. That's my pitch to all of you. Now, how does it work? So now I'm stepping away from the vision, and I'm giving you a very specific, how do we execute, where we is the NRP community, how do we execute on this vision? And I think the core slide is this one slide where I'm describing the software stack and I'm explaining how is NRP able to grow horizontally while at the same time grow vertically. And so the main rationale for this software stack and is 20 years worth of OSG experience, and I don't know how many years, as Larry can tell me, of PRP experience, where in essence, what we learned is that one size doesn't fit all. When you're trying to integrate, when you're trying to grow horizontally to 4,000 institutions, you have to have a variety of points where these institutions can hook up to, because different institutions have different cybersecurity requirements, different requirements for control. And control costs money. If you want to control something, you have to have the effort to be able to exert that control. And what in our vision in NRP, we have the vision of a software stack, if I can figure out how to move this, a software stack where there are multiple layers all the way from very close to the hardware, IPMI, to all the way at the batch system and storage system layer. In other words, you can horizontally add yourself in either by the PNRP project running everything that you have as all the way from IPMI up, or by you running your operating system and then you joining your operating system into the NRP Kubernetes infrastructure, or by you federating via Admiralty with your entire Kubernetes infrastructure to the NRP Kubernetes infrastructure. The main origin where we've exercised this is cloud. We've actually gone and integrated Google into NRP by virtue of Admiralty, using Admiralty. Or you can go one step further all the way to the top and say, we want full control. We want to control our batch system. We want to control our storage infrastructure. We want to have everything under our institutional control. Therefore, we're only federating at the OSG/path level. We're bringing our batch system into it, or we're bringing our storage system into it via OSDF. And any one of these layers, which ones you pick, depends entirely how much control do you want to exert and how much effort do you have to exert that control. If you don't have enough effort, then you have to go lower down in the stack because somebody else has to exert that control. And by having all of these different ways, you can actually offer a solution to people even with modest effort or people who don't care about control. Now, that explains how this goes horizontally. How does it go vertically? It goes vertically simply by the virtue of containerization. As long as you can actually build a containerized entire new thing on top of Kubernetes, you can plug it in and you can grow vertically. And we have examples where you actually have multiple organizations built in this up the stack, and different places in the stack, different organizations have collaborated with each other to build something vertically up that is much more powerful than any one of the layers. And so having explained how, from an NRP perspective, horizontal and vertical building goes, now let's talk a little bit about what's the status. This here shows you two maps. One map is the globe, and one map is the continental United States. And all of the flags that you see here are institutions, locations really, because as I told you yesterday, Kevin, what exactly is an institution is a very difficult question. And so we're counting something between an actual physical brick and mortar institution as a flag and something as a locality. Internet 2 is a perfect example. Internet 2 is an organization, but it has like 10 localities on NRP. So we count the 10 localities because it makes more sense. It's more natural. And how else would I define an institution like Internet 2 owns a piece of hardware inside Starlight, who is another organization? It is IPM I run by NRP, another organization at UCSD. It then, and on top of it is containerized OSTF, which is run out of Wisconsin. I mean, which institution do I pick, right? And so it's not so obvious. And so this is what we do. And then if you look at these 62 institutions integrated in NRP, 42 are integrated at the IPMI layer, and 20 are integrated at the K8S layer. And when I got these numbers first from Dima yesterday, I think, and I was actually shocked. If you had asked me, what are you guessing? I would have said 10% is integrated at the IPMI layer and 90% at the K8S layer, because it's easier to integrate for us at the K8S layer. But apparently the community thinks otherwise. If you had told me 10 years ago that there would be 42 institutions who give you that level of control of IPMI, I would have laughed you out of the room. Things have changed, and we're doing things that are totally novel and different. And ultimately, what drives it is the notion that it takes effort to exert control. And effort not everybody has, or effort not everybody wants to spend. And therefore, it's really important to have different ways of integrating. Now, what's actually on the platform? This is a list of, and I'm always a little bit feeling squeezy because supposedly NVIDIA hates us that we have gaming GPUs, but we have gaming GPUs, so what? And it is what it is. So this is the current infrastructure in terms of compute on the left, the current infrastructure in terms of storage on the right, and then there's CPUs in words underneath. So what we have are, I like to think of NRP as the NVIDIA museum, because to first order, every GPU since the 1080s that NVIDIA has produced, except for H100s, which we don't have yet, we do have somewhere. And the 100 others is basically so many others that I didn't want to count them because we have them in very small numbers. And so so what does this give you? It is, in essence, an AI infrastructure where you as a user can figure out what should I be buying, because my footprint works well on this, but I need a little bit more of that. And therefore, I can sort of get a handle on how much money do I really have to spend in order to get the job done. And that's one of the things that we provide as a side effect of being so diverse and heterogeneous. 13 petabyte of storage, and when Dima showed me that plot, I was a little bit shocked that it's so empty. All the gray is empty. So what this means for Nair, for example, we could donate you a few petabyte of storage. We wouldn't break out in sweat at all. And if that was desired, or to Kurt, where's Kurt? There we go. There's enough gray there to host all the NASA data that you want if it's too difficult to access the NASA data at NASA. Forget egress, just put it outside. Then I wanted to give you a little bit of a preview of attractions to come. Larry's going to give a talk tomorrow where he's going to summarize what all the science is that's happening. And in addition, we picked 8 individual scientists to talk about their projects, and we sort of picked them, some to give us an AI flavor. I admit, some were picked out of reasons, let's pick people who do a lot of AI. But in essentially, we picked people who make heavy use in some way or the other of NRP. And then what you see, there's some people today, they're mostly AI people, and some people tomorrow, they're mostly domain science people. And then there is an overlap. Some of the AI people actually do AI for a domain, and some of the domain people do AI in a domain. And those 8 people that we picked have consumed 385,000 GPU hours on NRP within the last 6 months. At a peak of 240 GPUs, and you see that it is incredibly like helter-skelter. And of course, there's the rest of, there's in the neighborhood, and Dima should correct me if I'm wrong, in the neighborhood of over 1,000 namespaces in NRP. A namespace is a project. So this is sort of 8 out of 1,000 namespaces, or maybe it's actually 20 because some of these PIs have multiple namespaces. Now, next, I wanted to show you an application on top of NRP that is very unusual because it's a distributed application that actually implements a content delivery network of sorts. And the application is called the Open Science Data Federation. It's run by Path, and it is an application. It has the notion of data is stored at origins and accessed via caches, and there's a global namespace across it all that is federated. So it literally has only 3 components: a namespace to bring order into the chaos of data, a caches to access the data, and origins to store the data so that it's always available. And out of the totality of that hardware that is in there, we have 16 origins, 6 of which are hosted out of NRP. We have 32 caches, 19 of which are hosted out of NRP. So a significant footprint of the entire system is actually hosted out of NRP, meaning it hooks into either the IPMI layer or at the Kubernetes layer. And the remaining ones, the other 10 and the other whatever 32 minus 19 is hosted at the higher layers where the institution runs everything all the way to and give us all the way, in some cases, all the way to they deploy the container. ESNet, for example, provides caches where ESNet deploys the container because they don't want us to have root access. So we give them a reference. This container has to be deployed, voila, off we go. Talking about Path more generally and OSG in particular, this is the map of 143 institutions joining at the batch or storage system layer. So you have 62 institutions who join either at the bottom 2 layers, and you have 143 institutions that join at the top layer. So we're getting somewhere around 200. I actually don't have a real count because we haven't figured out yet how to understand overlaps. I know that there's a fair number of overlaps, meaning people that are counted at the top and the bottom, because every time that you have an OSDF infrastructure, it will be counted at the top and the bottom, because NRP considers it integrated at the bottom and Path considers it integrated at the top. So there's some overlap. But we're getting to about 200 institutions. So we're only an order of magnitude away. For physicists, order of magnitude, what's an order of magnitude among friends, right? So we ought to be able to figure out how to do this. A scale from 200 to 2,000 in the next 5 to 10 years. Now, switching topics, bridging education and research by having them coexist on one platform. I'm talking very little about this because we made education and NLP a special focus of this workshop by having 3 different sessions, on 1 tomorrow and 2 on Friday, where that is discussed in great detail by the people who actually do it rather than me talking about it. But basically, in a nutshell, Jupyter rules to first order. Now, I wanted to, however, to point to 2 of those, in fact, 3 of those different talks. And one is the GP engine. You're going to hear more details on Friday by Alex Hurd and Derek Weitzel. And the other one is the Scenic AI resource. And I think the official announcement date is Monday of Scenic Air, if I'm not mistaken. Tom, is that right? Chris's talk, so Friday. So I'm actually jumping gun here a little bit. So it's an initiative that we do together with Scenic, and you hear all about it on Friday by Chris Bruthner and Jerry Sheehan. And it combines a CC Star Award together with Scenic's in order to serve the CSU system. And the third one I wanted to mention is a talk on tomorrow by Michael Farley and Valerie Polikar, where Valerie's organization runs the infrastructure that UCSD uses for its own courses. It's basically a carbon copy of NRP, and meaning they run a Kubernetes infrastructure, they do Jupyter Hub just like NRP, they do all this, but given that UCSD exercises a special way of insanity that education dollars are never allowed to meet research dollars. So there is a separate infrastructure for education at UCSD from infrastructure at research. And don't ask me why and how. I mean, I can tell you how, I don't know why. And then what my main message here is I'm listing courses that have actually been taught. These are names of courses that have actually been taught. It's a subset of the 50-some courses from spring quarter 23. And I wanted to, and then I've put in blue the ones that I think are clearly AI. And the main point is that there is much more to compute and data needs than just AI. The theme we see that education needs cyber infrastructure goes well beyond just AI. It's embedded into all the STEM fields at this point. In fact, at UCSD, we have STEM fields that have defined their programming language that is required from every major in order to build on it, in order to do this. Then the training event yesterday, we had a registration limit of 20 people. Somewhere between 35 and 40 showed. So we had party crashers at the order of to increase the number by a factor of 2. I acknowledge that clearly there's much more demand than we prepared for. And I acknowledge that next year we'll do better and prepare for more people and make it available at a larger scale. Basically pick a bigger room. Now, last topic to talk about is NRP brings computer science R&D and domain R&D onto the same platform. Why? My answer is very simple. I want to blur the line between testbed and production CI simply because, as a domain scientist, what all of this new technology brings me as challenges, I want to be socially connected with the people who do the CS R&D so that I have a fighting chance to digest that on a finite amount of time into my domain's infrastructure. And the way to do it is by having a social platform that we share, where we bring computer scientists together with domain scientists, and interesting things can happen. And that's what NRP tries to do. And so now the obligatory why, and I love to blame others for the why, and I'm blaming others here. Mark Papermaster, the CTO of AMD, he gave a talk at a Dell shindig that I went to, and he had this slide here, and basically said that CPUs were very general purpose. GPUs are much more narrow, but are much better in performance. So there's a trade-off between performance and generality. And he's predicting that the future will even be more narrow and even higher performance per amount of silicon invested. And that is domain-specific compute architecture. And so the CTO of one of the largest technology companies sees that as their future. And then I went to John Shelf, who always is good for good viz on the end of Moore's Law. And he showed this slide at Supercomputing 23. What is this slide? It's the x-axis is time. The y-axis is the compute power increase over the last 11 years at that time in time of the top 500. So basically, John went and mined the top 500. For every year, he looked 11 years in the past, how much compute was there 11 years in the past, how much is there today, what's the ratio, that is the y-axis. So it used to be 1,000 between 2004 and 2013. Then something happened, and since then, it's been going down ever since. So we lost 2 orders of magnitude scale for free, so to speak, in the last 10 years, say. It's about 10 these days. So that effect is what drives both the architecture innovation in the technology industry, and that also drives investments. And as an example, I point to the Jump 2.0 initiative out of the Semiconductor Research Corporation, they're basically giving grants. They've given grants out to people like Rajesh sitting here in the front and Tayana in order to develop next generation architectures for science. And Tayana is a co-PI of NRP. And so one of the objectives of NRP is, I like to think of it as we're the toy store. We want to be the toy store with toys for people like John Graham and Tayana Rosing and computer scientists to play with interesting new technology. And we do this because we can horizontally and vertically grow. We can put weird stuff in because Kubernetes allows us to put weird stuff in. And that is, so NRP supports FPGAs, P4 switches, NVIDIA DPUs, HE access. And the reason why it's scary to me is not necessarily that it is a new compute platform. I'm less worried about the transition from CPUs to GPUs. That's bad enough. But what I'm really worried is that all the dumb devices that we used to know, they all now can be purchased with externally compute capability. And not only can they all be purchased that way, they also all come with their own computing paradigm. So there is a paradigm per device. And as a domain scientist, that's really scaring. Because not only do I have I have to re-engineer my software, I have to re-engineer my entire architecture to benefit from all of these different compute paradigms, no matter what the device is. And so I think the NRP is trying to do a social cohesion experiment, bringing computer scientists onto the platform. And that's ultimately why I wanted to be co-located with Fabric, because Fabric can do this with NRP at the networking layer. And so what NRP offers to Fabric is 400 gig WAN infrastructure that is connected all the way to compute and storage. And so the infrastructure at SDSC that we have, there's basically 56 FPGAs. And then there's in addition 400 gig P4 programmable switches. I think we have 2 right now and a third one in a different place on campus. So there is you can reach into us from Fabric. There is then the 8 NVIDIA HE access, each with 8 M180 gig. And there is 400 terabytes of NVMe, and there's a Fabric node itself hooked into the NRP 400 gig networking infrastructure. And so I want to challenge the Fabric community, figure out what of this is useful to you. How can we offer co-allocations between Fabric and NRP to make interesting things happen? And I want to give you one example. And the example literally started using a testbed for measurements yesterday. A student of mine had the opportunity to send traffic around for a walk through the US. We basically, together with ESNet and Fabric, we created 6 loops at different RTTs from 6 milliseconds to 130 milliseconds. And then you could pick which route, which loop you want to take, and take your data for a walk. And then you could measure what performance do you get, how much CPU you consume in order to fill the pipe. We filled, Ashai yesterday filled the pipe up to 100 gig. You see one plot on the side for different and RTT. We're going to use that. We're going to go to town with that infrastructure over the next little while to understand how our software stack all the way to the top operates in an environment where we'll 400 gig pipes given the limitations of TCP/IP. Basically, that's what it boils down to. And I encourage other Fabric customers to figure out how can you use this kind of infrastructure for interesting things. You're probably going to come up with ideas that we can't serve right away because that's the nature of the beast. NRP is still in the testbed phase. We will innovate with you on figuring out how to make this work. So you have to be a little bit patient, but the offer stands. Your creativity, our creativity will figure something out. Finally, summary and conclusion, NRP has a very ambitious vision. It's horizontally open, it's vertically open, and we have education is increasingly requiring significant CI. I think, given that PNRP, the project that drives NRP at the bottom right now, is only a year old right now, we're off to an excellent start. And we're off to an excellent start to large part because we're standing on the shoulders of giants, right? We build on other people's work prior. And there is lots more to come over the course of the next 5 years. Open for questions.
Kate Cahey, University of Chicago. Frank, couple questions, both relating to the community aspect. The first one, education. You're seeing much increased need for infrastructure from education. In Chameleon, we're seeing it too. So it was interesting for me to see that there is this coincidence of perception. Are you aware of any studies that actually put numbers on that phenomenon? Because we're seeing a groundswell, but it's, you know, if that's all, right? If all your evidence is anecdotal, you don't know.
Yeah, I don't have a study that actually measures it. I just see it. I see it at my own institution, and I see it across NRP that more and more institutions have discovered NRP in order to exercise their educational and satisfy their educational needs for cyber infrastructure. I don't have it. I don't.
But it also stands to reason as more and more science as such is based on computing, right? So I was just curious if you were aware of any studies, because there should be something like that somewhere.
I think this deserves some study. I can tell you what's driving it in my own institution. Mm-hmm. I was on the committee that made the decision in the physics department to go that direction. And the physics department literally had to ask itself, how do we have a computational physics major, in a bachelor degree, basic physics bachelor degree, but it has a computational specialty. How do we make sense out of that going into the future? It used to be all just simulation. It was basically driven by large simulation type things. And increasingly, it's not driven by that anymore. It's driven by data, and it's driven all over the place. And so we had to reconcile with the fact that we need to bring in a common baseline for the students very early on, so that then all faculty that teach any course in physics can build on that baseline and can make a decision, at what level do I want to bring compute intensive work into the classroom? And so we chose to base ourselves on Python. Mm-hmm. Because and not Python because Python is a great language, but because NumPy and SciPy exist. It was that simple. And so we actually teach a course. The physics department here teaches a course where the main objective, we use physics as a hook, but in the end, the main objective is to introduce students to Python, NumPy, and SciPy. Mm-hmm. And I am told, and I was not involved in this, that the School of Biological Sciences has made a similar decision. And they've chosen R because R seemed the most appropriate language for the biological sciences to base themselves. And it was all about data. Yeah. And I suspect that this kind of thing is happening at lots and lots and lots of universities and colleges of all sizes. But I don't know of any study that actually would say.
So for tools, we should talk, because we actually also had Chameleon user meeting focused on education last year because of the same reason that you're looking at it right now. But the second question also relates to, you mentioned that NRP is a vehicle for socializing computer science research and domain science research. And that's, again, also something we're interested in. And so my question is, are you just doing it via all those communities using the same platform, or do you have a structure around it? Or by structure, I mean social structure, events, any kind of organization. How do you promote that socialization?
As most of the successful things I've done in my life, I make it up as I go, and so I don't have a structure. I don't know how to do it, and we're gonna somehow bumble along and figure it out. We wrote into the PNRP proposal a structure, and we wrote into it the notion of a matrix. And the idea was that the PNRP had different thrusts that are technological and different science domains that we wanted to serve. And that we picked as showcases people who fit into this matrix in such a way that we populate the matrix such that there's overlaps. And so we then hypothesized or claimed in the proposal that the creation of this matrix will lead to voila.
Yeah.
Now, I think that as we actually exercise this, it needs a lot more than just putting a pretty matrix on a piece of paper.
Yes.
So I think that figuring out what exactly the processes are, we haven't done.
Yeah.
And I would love to, I owe you integration of NRP and Chameleon. It is still on the to-do list.
Yeah.
It's an obvious thing we need to work together.
Yeah. Thank you.
Any other questions?
Harvey Newman, Caltech. For the next 5 years, do you foresee sort of system level development that will look after workflow? So, in this global network advancement group and our working groups, we're working on system level development that foresees the fact that there's a mismatch between the end system's raw capability and the foreseeable, affordable network infrastructure. And so, do you foresee that NRP and its partners can build a sort of end-to-end system, including workflow management, maybe agent-based architecture, to help with executing series of tasks and so on over the next 5 years?
Short answer, NRP can't solve that problem and can't do that. It's not, it would explode the financial envelope, meaning the PNRP project. So I have to be keeping my nomenclature right in my head. The PNRP, the funded PNRP project can't do that. The NRP community can do that. And so this goes back to the pedal picture. I think there is space for pedals to figure out which solicitation out of the NSF, the DOE, the da-da-da-da-da-da are appropriate avenues to push for these things. And I'm happy to write a letter of whatever for anybody that wants to do that and wants to build on and what we have. Because I think those kinds of things, figuring out which of these paradigms make sense for what is actually very hard. And I think the experimentation required for this needs to be funded separately from the things that I know are funded today. And voila, so, knock yourself out.
So I think it takes a deeper discussion, because we had entered what you just said, and it's very difficult also on the agency side to comprehend what we're trying to do, to understand what we're already capable of, and to understand the value of solving some of these challenges. So I think I agree with you, but we need a deeper discussion.
And let me add one more thing too, and then we probably have to stop. The places where this is actually exercised is industry. There are new startups that are doing exceedingly well and are solving problems, providing things that are genuinely new and in their performance characteristics. And they actually use some of these paradigms. And it's actually very interesting to see that this is actually happening. I haven't seen it as much be valuable. I can't afford those products because they're too expensive. And so somehow science is behind the curve.
I have to respond briefly that if we have enterprise level control, you talked a lot about control and how difficult it is. Industry can often do this. They have an enterprise level system and they can propagate the system. They're driven by the profit motive. It's self-consistent and so on. In our case, it's not only a question of even wider geographical dispersion, but also the kind of collaborative work that industry doesn't have, and that brings additional complications.
Fair enough. Okay, next. What's next on the agenda? Tom? Is Dinesh next? Yeah. Dinesh. One more question.
Hovak Migrowski, UC San Diego. Very quick question. What do you think about the future of RISC-V in HPC?
I'm waiting to see the Europeans sort this out because RISC-V. I see the first big HPC systems to arrive with RISC-V, not in the US. I don't see that happening. Maybe I'm wrong, but I don't see it happening. And so I see that the first machine of size will show up in Europe, and then we'll see.
Okay.
We'll compare notes.
Thank you.